Okay, let's take a look at graphing the sine and the cosine curve. So go ahead and take a look. Did this over the last couple days. Share. And what we have is the sine curve. So what the sine curve actually does is it takes the sine curve actually takes the unit circle and it kind of expands it over the XY axis, or if you will. So what happens is, if you remember with your unit circle, when we have our unit circle, we go around the unit circle and we start at 0 pi. I'm going to copy my unit circle right now. So if you have our unit circle, what we do is we start here, and remember that this is always our cosine part, the X, and this is our sine part, the Y. So we're dealing with the sine curve. So what it says is when we're at 0 radians, our value of sine is 0. When we're at pi over 2 radians, our value of y is 1. So what that means is when I go to graph this curve, when I'm at 0 radians, the value of my function is 0. But when I'm at pi over 2, I'm at 1. When I'm at pi, I'm back to 0. When I'm at 3 pi over 2, I'm at -1. And when I'm at 2 pi, I'm back to 0. So this is what a sine curve looks like. It kind of goes like this. All the points. So what ends up happening, that's what the sine curve looks like. And actually it is kind of mirrored. There's a cycle to it and it actually keeps going over here. So what ends up happening is we actually have a sine curve that looks like this. So again, what the sine curve is it's going around our circle, looking at the sine parts at each radian. So 0, 0. Pi over 2 gives me 1. Pi gives me 0. 3 pi over 2 gives me -1. And then actually when you come back here, this is actually also 2 pi. 2 pi also gives me 0. And if I go backwards, it does the same thing. So that's the sine curve. This is what the sine curve looks like. It's the parent function is of the sine, kind of has this like cyclical motion to it. And some of the definitions we talked about in class were the height of this thing right here. When I go up here, that guy right there is called the amplitude. Amplitude is always a positive number. So in this case, the amplitude here is equal to 1. We also have an amplitude here, and that amplitude is also equal to 1. So what we deal with is we deal with the amplitude of it, and the other piece we deal with is what's called the period. And the period is going to be how long it takes to go through one kind of iteration of the sine curve. This is called the period. And in the case of this function, the period is 2 pi. So that's our sine curve. We also have a cosine curve, and the cosine curve would follow the x parts going around the circle. So for 0, it would be 1. For pi over 2, it would be 0. For pi, it would be -1. So again, let me kind of sketch that one for you. I'll do it in a different color. That one would be green. So at 0, it's 1. At pi over 2, it's 0. At pi, it's -1. At 3 pi over 2, it's back to 0. And at 2 pi, we're back to 1. And what ends up happening is here's what my curve looks like. Kind of goes down and then back up and then down again. So there's my cosine curve. And again, it is mirrored over here. So this cycle just keeps going. So we have that. So my curve kind of goes like this. So again, that's my cosine curve. If you kind of look at them, pull up a little bit so we can look at both at the same time. There's my sine, there's my cosine. They look similar in the sense, but they're kind of shifted just a bit. And we're going to talk about that shift in a moment. But again, it has an amplitude. So if we look here, excuse me, the amplitude here again is 1. So we got an amplitude, the height of it, the amplitude is 1. And again, the amplitude, if you looked here, that amplitude is 1 as well. And it also has a period, and the period again is going to be 2 pi. So we look here, and we have a period of 2 pi. Okay, so now here's what you can do when you play with this. And we did it with the calculator. So again, I'm going to kind of have the calculator to show you a little bit what happens. So again, look at the calculator, and we're going to talk about what happens when we play with these numbers. So I'm going to do, so with my calculator, first thing you always want to do to clear it is you want to do second. And second plus 7, 1, 2. That's going to clear your memory. You want to do that every time you start with this, just to get the stuff out of the calculator that you don't want to work with. We go to y equals, and what we're going to do is we're going to put in the sine curve. So sine of x, close parentheses, and to graph it, we hit zoom, and then 7. So there is our sine curve. It's going to look very similar to that curve right there. Okay, so it kind of shows me my sine curve. Now what I'm going to do is we're going to play with the number up front. So what I'm going to do is I'm going to make it 2 sine, and then I'm going to do x. So what I did is I put a number in front of it. And again, what we did in class, we zoom 7'd it. And when we do that, here's our sine curve. Next one's going to be our 2 sine. And if we look at it, what ends up happening is notice the amplitude increased. What it does is the changing of the A increases the amplitude. It makes it taller. So what I pointed out is notice how it still stays with the same intercepts, the same x-intercepts. It just stretches the top, it stretches the bottom down. So playing with that A changes the amplitude. So when we actually play with this letter right here, this A, this is an amplitude change. And what ends up happening with the amplitude is that if that A is greater than 1, it's going to do a stretch. If that A is between 0 and 1, if it's a fraction, it's going to do a compression, kind of flattening. What I mean is, watch what happens when I make this y equals 1/2 x. So I'm going to do alpha y equals the fraction 1/2, 2, and we're going to zoom 7 it again, and you'll see here's my sine curve. And then if you look at this, is the 1/2 sine x. So I kind of compressed it. Okay, so that's one thing we talked about. We talked about that a couple classes ago. The next thing you can actually play with when you do this is I can actually do the following. What I'm going to do is I'm going to go ahead and I'm going to delete out the fraction. And what I'm going to do is I'm going to put in a negative sign. So what I'm going to do is have sine x and negative sine x. And then remember the negative button is down here. It's that guy. We're going to zoom 7. So again, there's our sine curve. And then our negative sine curve. What it actually does is it takes the blue and it kind of flips it over. So what it does is it does a reflection. So the A also, if the A is negative, the curve is reflected. Okay, so that's what happens when we play with the amplitude. We talked about that. I'm going to go back to my y equals, and I'm going to show you again what happens when we play with another thing. So I'm going to make this sine x, close the parens important, plus 1. And now what I'm going to do is I'm going to zoom 7 it. So again, there's my original sine x. And if you notice what ends up happening is it took this curve and it shifted it up, it moved it up. So what happens when you play with this D is you do a vertical shift. You do a vertical shift, and remember vertical is up and down. And what happens is if my D is greater than 0, it's an upshift. If my D is less than 0, it's a downshift. So since this was a +1, the curve went up. If it had been a -1, this red curve would have gone down and been below the blue curve. So that's what happens when we played with a D. Okay, again, just kind of reviewing things we talked about in class. The next thing I'm going to do is I've now shifted it up and down, and I've compressed it and I've stretched it. So everything has been done vertically. So it's up and down vertically, it was compress or stretch vertically, up and down. So now what I'm going to do is I'm going to play with left and right. I'm going to actually be able to shift the thing left and right. And what I'm going to be able to do is compress it, and I'm going to be able to stretch it and stretch it horizontally. So what I'm going to do here now is I'm going to play inside the parentheses. And what I'm going to do here is I'm going to make this, and here's my pi right here. It's over the caret key. I'm going to make this x minus pi over 2. I'm going to close the parentheses, and I'm going to delete that one. So what I've now done is I've put something inside the parentheses, a -2, and now I'm going to zoom 7 it. And again, we start with my sine curve. And then my pi over 2, it looks a little bit different. what it's actually done is it's done what's called a phase shift, and it's kind of moved it down. So what has happened in actual is the following. I started out with this guy at 0. What the phase shift did is the phase shift went ahead and said, I'm going to shift this guy down here to start. So this point moved here. This point is going to move here. So what's happening is I'm kind of shifting all of these points down. So this point would shift here, and this point would shift out here. And what happens is I took my curve. That's if I could connect them. And what I did is I went ahead and I shifted my curve from one space down. So what I had said was this C part is going to be called a phase shift. And what a phase shift does is it runs opposite the way you would think. If C is negative, we're going to shift it to the right. If C is a positive number, we're going to shift it to the left. So like if I see a minus sign in front of it, I'm going to move it to the right. If I see a plus sign in front of it, I'm going to move it to the left. So again, that's how we shift it left and right. And the last piece that we played with is we played with B, and that's actually going to change this period. So again, let's put the calculator back. And again, what I'm going to do is I'm going to clear that out, and I'm going to make this sine of, and let's do 4x. And now what I did is I played with the number in front. Again, I want to show you what happens. So again, we start with sine. And 4x, it's going to look weird. Now, what it does is it looks like it makes more of them. It does, but here's what it's really doing. It's taking what used to take 2 pi, what used to take this amount of time to do, and it's making it a shorter period of time. So it's kind of compressing the time. So what is happening is, in this case, is it used to take me from here, 0, 0 to 2 pi to get through this up, down, up. Well, what I'm telling you is when I change that number to a 4, it is getting it done in 1/4 of the time. So what it's really doing is it's doing this curve right here. So from this piece of the red on the right side of the y-axis is now this. What I've now done is I've taken this long red curve and I've compressed it to blue. What I am doing is, again, to make it a little bit clearer. So what happened is what before looked like this. So we have this. And that was going from 0 to 2 pi. Now what I'm saying is I'm going to get it all done by right there at pi over 2. So what I'm going to do is I'm going to go up, I'm going to go down, and I'm going to come back, and I'm going to be there. So what it does is the B part changes a period, and it's the only formula we need to know. The period is equal to 2 pi divided by B. So in this case, what we did in the calculator, we did 2 pi over 4. So that tells me that the new period is pi over 2. Well, again, what this saying is it's taking less time to get through that up and down. So that's how you play with a curve, and the same holds for cosine. If you play with A, you change the amplitude. So you either stretch it. If it's greater than 1, compress it. If it's less than 1. If it's negative, you flip it over. If you play with the B, you change the period. So if it's greater than 1, what ends up happening is you compress the period. If that B is between 0 and 1, if it's a fraction, you actually extend the period. You stretch out the period. It takes longer. The C actually shifts it horizontally left to right. And again, negative numbers send it to the right. Positive numbers send it to the left. And the last thing is the D. That's my vertical shift. That shifts it up and down. Positive number shifted up. Negative number shifted down. So again, what we talked about in class was this. What we had was this right here. This is how I'll wrap it up. What we know is that A is the amplitude. And what we knew about the amplitude was the following. If A was greater than 1, it was going to be a stretch. What I mean by a stretch is it's going to make it taller. If A was between 0 and 1, we're going to have a compression. Technically make it shorter. If A is a negative number, then there is a reflection, or we called it a direction change. B is used to find the period, and the formula is period equals 2 pi over B. Sorry. C is the phase shift. And if we have C as a positive, C is a positive number, the shift is to the left. If we have C as a negative number, the shift is to the right. And then our D is our vertical shift. And what that says is that if D is greater than 0, it's going to shift it up. If D is less than 0, it's going to shift it down. And that's what we did over the last 2 classes. I wanted to kind of summarize it. It's a little bit of a longer video, I know, but please use that as reference. We're going to actually ask to be describing those sorts of things. So hopefully that helped. Stop. And good luck, and always ask me questions in the